Hello everyone. Today we're going to learn lesson 8.3, which is multiplying polynomials. There's two parts to today's lesson. I'm going to outline both in the video. Hopefully they go okay. If there's going to be issues, it's probably going to be in part 2. So if a lot of you are telling me that there's problems with part 2, there will probably be an extension to the video posted just on the second part of the lesson. But the first part of the lesson should go okay, hopefully for everyone. Now it's really, really important that we get what we're going to talk about today down really well, and then roll it into lesson 8.4, which is equally important, so that when we come back around to lessons 5, 6, and later, we're able to turn this whole process backwards, because that's where we're headed when we go into division. All right, so just to recap really quickly what we did last time, because that's going to tie us into this time. Remember when we do monomial times monomial, like x to the third times x to the fourth, we add the powers, that would become x to the 7th, 3 plus 4 is 7. Likewise, if we had 5x to the third times 2x to the 5th, that would be 5 times 2, coefficients first, 10, 3 and 5 makes x to the 8th. Multiply the coefficients, add the powers. Then yesterday we pushed into multiplying monomials times binomials, trinomials, and any level polynomial. Things like 3x squared times 2x squared minus 3x minus 5. In order to do this, we need to distribute. First monomial times monomial. 3x squared times 2x squared is 6. 3 times 2 is 6. X to the 2 plus 2 is 4th power. Second monomial times monomial. Remember, coefficient times coefficient. 3 times negative 3 is negative 9. X squared times x to the first is x to the third power. Last monomial times monomial, 3 times negative 5 is negative 15. X squared times no x's is x squared, and that problem would be completed. All right, now we're going to fast forward into today. Today we're going to work on binomial times binomial situations and polynomial times polynomial situations. Now they all technically work the same way as we were working old problems. These distribution problems all work following forward. The only difference is we have a special type of distribution that we do on binomial times binomial that we do not do on polynomial times polynomial, which would be trinomial times trinomial or binomial times trinomial, etc. Okay? The special type of distribution is called FOIL. FOIL is an acronym. It stands for firsts, outer, inner, last. So we're going to look at our binomial situation. Let's work with a simple one first. X plus 5 times x plus 2. I'll let everyone get that written down. down and settle it onto their paper. Our firsts represent the first term in each of the binomials. So our firsts would give us x times x, which in this case, x times x is x squared. The next term we're going to work with are our outers. Our outers are the two terms that are farthest away from each other. Way outside. Outsides. In this case, our outers are x times 2. X times 2, which gives us 2x. Like I said before, this is like a really weird distribution. So instead of just going from the outside number into all the inside numbers, we're connecting special pairings. So we have our firsts, our outers, our next one is our inners. Our inners are the two that are right next to each other, but in different binomials. We don't multiply the things in the same binomial. So the x never gets multiplied to the 5, nor does this x ever get multiplied to this 2. Everything from this binomial must get multiplied to everything in this binomial. So our inners, in this case, are 5 times x, which is 5x. And finally, we're going to work with our lasts, which is the last term in each binomial. So in our case, our lasts are 5 times 2, which is 10. Now, just like when we distribute, all these terms that we just multiplied out are going to get added together. So normally you don't have to lay them out like this. It's kind of nice to, so you can see each piece separately. And if you want to sit and color code them and write out each piece separately, I think that's wonderful, because it gives you an opportunity to see each of your distributions into the two binomials. But you really don't need to if you don't want to. So we're going to line them all up. Firsts, x squared plus outers 2x plus inners 5x plus lasts 10. Now if any of them were negative along the way, we'd have some minuses in there, which we'll come across as we do more and more of these. But on this first one, everything's plus. Now you'll notice in this case, and in a lot of cases on these, we do end up with some like terms here in the end. It is not the end of the world if you don't notice the like terms here. Mr. P is not going to care if you get from here to the end. Just like yesterday in the lesson, if we don't combine like terms, it's totally fine. It's totally fine to circle this and say that this is my answer. However, there's one more move I can make. This 2x and this 5x can be added together. Remember that when you add x's together, you add the coefficients, leave the variable's power alone. So 2x plus 5x is 7x. X squared plus 7x plus 10 ends up being the solution to that problem. I'm going to step back and give just a second so that everyone has an opportunity to copy that down. We're going to end up doing a lot of practice problems here. So If you need to pause this video at any time to copy things down, or you need to rewatch some of this stuff, that's totally okay. Do whatever you need to do. Mr. P won't even know if you've rewatched the video 12 times or haven't even watched it all the way through. It would be slightly disappointing if I put all this work into a video and you didn't even watch it. But that is life. Alright, so let's take a look at this next one. Y minus 2, y plus 4. I'm going to go ahead and highlight the zones I have here with my colors. And my outers were red. Alright. Color free on this one, but I'm going to mark them off because I always mark them off. First, give me y and y, which is y times y, or y squared. My outers is y times 4, y times 4, which is 4y. My inners now you'll notice on my inners the 2 here is negative. So that's negative 2 times y, which is negative 2y. And then my lasts, again, the 2 here is negative. So I have negative 2 times 4, which is negative 8. Now we can line them all up. First, y squared plus outers 4y plus the inners negative 2y plus my lasts negative 8. Now you'll notice that when I put the negative 2y and the negative 8 in, I put them in as just minuses. You can do plus negative if you want to. It doesn't change what it says. Now I can go ahead and put this 4y with that negative 2y because they are like terms, just like I had the 2x and 5x over here that were like terms. Y squared plus 4y minus 2y minus 8 ends up being y squared plus 2y because 4 plus negative 2 is 2 minus 8. And that solution is finished. I'm going to move over to this side and get the next problem set up. Give you a chance to copy that one down. I will go back to color coding this one. This is the point in time where some people will probably be fast forwarding me. I sound even funnier fast forward than I do regularly. All right. Next problem. B minus 7 times B plus 3. First term in each problem. B times B, which is B squared. Outers, the two numbers that are farthest away from each other. B times 3, which is 3B. Inners, the two numbers that are closest to each other. Negative 7 times B, which is negative 7B. And my lasts, the last value in each binomial, negative negative 7 times 3, which is negative 21. Line them up together. B squared plus 3b minus 7b minus 21. B squared minus 4b, because I have like terms, 3b and negative 7b, which gives me negative 4b. Minus 21. Hopefully this is starting to come together for everybody. I'm going to do one that's slightly trickier because it has a leading coefficient on it. Just means a number in front of one of our variables. And then I'm going to go into part 2 of this. Then I'm going to do some homework problems and get you going. Without color coding. Last example, 4n plus 3 n plus 9. Firsts. When I don't color code, I like to label. 4n times n. Remember, I do coefficient times coefficient. 4 times 1 is 4. Power, power. I add the powers. N1 and N1 makes N2. Outers. 4n times 9. Coefficient times coefficient. 4 times 9 is 36. N times no n is n. Inners. Inside values. 3 times n is 3n. And my lasts. Three times 9, which is 27. Line them all up. 4n squared plus 36n plus 3n plus 27. Again, we have like terms out here in the middle. Typically, your like terms will be in the middle. Not always. Don't assume that will always be true, but it is typically true. 4n squared plus 39n plus 27. Again, remember, when you add n's together, you only add the coefficients. 36 plus 3 is 39. When you multiply n's together, you add the powers. N times n is n squared. It is very important to separate those two concepts. To do our next problem, we're going to take polynomial times polynomial. When I do these, this is trinomial times trinomial, which is worst case. Trinomial times trinomial, right? They're going to have some binomial times trinomials and some trinomial times binomials, but this is the worst case, trinomial times trinomial. To do this, we're going to use distribution, just like yesterday. Only the distribution gets really crazy, like, not yesterday, just like the last lesson 8-2. The distribution gets really crazy here though. We're going to take each of the terms from the first trinomial, and distribute them through the second trinomial. So that x squared is going through that whole trinomial. Let's work there. X squared times 5x squared is 5x to the 2 plus 2, which is 4. Remember, coefficient times coefficient, add the powers. X squared times 3x. Coefficient times coefficient. 1 times 3 is 3. Variable times variable. X squared times x to the first is x to the third. Last one. X squared times -4. Coefficient times coefficient. 1 times 4 is 4. Remember that it's negative because that one is negative. X squared times no x's is x squared. Now that we've multiplied through the x term to each of the 3 pieces in our second trinomial, we're going to do the same with the second term. Keeping in mind that this is -4x. And it's going here, and here, and there. Gets to be quite a bit. Take your time and make sure it's done right. -4x times 5x squared. Coefficient times coefficient. -4 times 5 is -20. X times x squared is x to the third. Second monomial multiplication. -4x times 3x. -4 times 3 is -12. X times x is x squared. Remember, that's an x to the first. Last one. -4x times -4. -4 times -4 is positive 16. X times no x is x. I wish I could say we were done, but we're not. We've done 2 of the 3 from the initial trinomial, but we have to do the third. Multiply through this 5. I'm going to use the second row on my problem here, just because I've run out of space going out. Five times 5x squared is 25x squared. There's a plus in between here and there. 5 times 3x is, 5 times 3 is 15x. And 5 times -4 is -20. Now we're going to cruise down the line and put like terms together. There's only one x to the 4th here. 5x to the 4th. Check. There are a couple x to the 3rds. This one and that one. 3x to the 3rd is going to get added to -20x to the 3rd, which makes -17x to the 3rd. Next one. X squareds. There are 3x squareds. This one, and that one. -4 and -12 makes -16. When I take that -16 and add it to 25, I end up with 9. x squared. You can check that out if you want to, but negative 16 plus 25 is definitely 9. Cruising on down the list, I have a couple of x's, 16x here and 15x there makes 31x. And I only have one constant, negative 20. And that problem is completed. Hopefully you were able to push through that with me. All right, I'm going to do a couple of the homework problems. They're on page 509 if you want to follow along. If you're still copying that one down, go ahead and pause the video at this point in time because I know there was a lot going on there, or rewatch what I did. Problem number 12 is the first problem I'm going to work. It is 3c minus 5 times c plus 3. I picked only tougher ones with the binomial multipliers. I'm also going to do problem 16, which is 5y minus 4, 3y minus 1. My firsts give me 3c times c, which is 3 times 1 is 3, c times c is c squared. My outers give me 3c times 3, which is 3 times 3 is 9, c times no c is c. My inners give me negative 5 times c, which is negative 5c. And my lasts give me negative 5 times 3, which is negative 15. When I put them all together, I have 3c squared plus 9c minus 5c minus 15. 9c and 5c are like terms, so I can reduce that down to 3c squared plus 4c minus 15. Very similar on number 16. Firsts, 5y times 3y. 5 times 3 is 15, y times y is y squared. Outsides, 5y times negative 1. 5y times negative 1 is negative 5y. Insides, negative 4 times 3y. Negative 4 times 3 is negative 12y. Lasts, negative 4 times negative 1, which is 4. Line them all up. 15y squared minus 5y minus 12y plus 4. When I take my negative 5y and negative 12y and put them together, I end up with negative 17y. Hopefully I didn't go too rapidly through that one for everyone. I know this video is pushing the long side of things, and I knew it would because we had a lot to go through. The last one I'm going to do is 28, and I'm not going to fully do 28. I'm just going to get you rolling on it. Problem 28 is x squared plus 5x minus 1 times 5x squared minus 6x plus 1. We're going to do this the exact same way distributing through the first one into the second one. X squared times 5x squared. Coefficient times coefficient, 1 times 5 is 5. X squared times x squared, add the powers, x to the 4th. X squared times negative 6x. Coefficient times coefficient, 1 times negative 6 is negative 6. X squared times x to the first gives me x to the 3rd. Times out to the last, x squared times 1 is x squared. Going through the middle term. 5x times 5x squared. 5 times 5 is 25. X to the first times x squared is x to the 3rd. 5x times negative 6x. 5 times negative 6 is negative 30. X times x is x squared. 5x times 1 is 5x. Now my red terms. The nice thing about the last term is usually constant. Negative 1 times 5x squared is negative 5x squared. Negative 1 times negative 6x is positive 6x. And negative 1 times 1 is negative 1. It is now your job to take that to completion. Put the like terms together and you're done. Now, just like before, if you don't combine your like terms, it is not the end of the world. This would be an acceptable answer, but there's another leap that you can go through here. If you're having trouble in the bottom problems, make sure to either reach out to me or watch the follow-up video that's probably coming to help people through the problems in the bottom of the lesson. The homework today is 12 through 30. It's a little longer than the previous lesson because there's really 2 pieces to it, but I will come out with an extension video to help people through the back part.